Hi everyone, my name is Nadia Dahmani and I'm from Zayed University. My today's talk is about my research entitled The Impact of Grouping Efficiency Measures in Cellular Manufacturing Systems. The outline of my talk is as follows. First, I will be describing the problem that we are tackling in this research. Second, I will be presenting the case studies that we choose to conduct our research, followed by a sensitivity analysis of different evaluation measures. I will be concluding by a discussion and some remarks. The group technology problem is a management philosophy about efficient problem solving based on the knowledge about groups, the identification of part families and machine groups in the design of cellular manufacturing systems is commonly referred to cell design or cell formation. Grouping the components into families and machines into cells results in a transformed matrix with diagonal blocks where ones occupy the diagonal blocks and zeros occupy the off-diagonal blocks. The resulting diagonal blocks represent the manufacturing cells. Two case studies have been chosen in order to analyze and study the optimality of manufacturing systems. The first one is from Boktor 1991. It contains 7 machines and 11 parts. The second case is from Nair and Narendran 1996 and contains 24 machines and 40 parts. Different algorithms have been used to solve these problems to optimality, and the designer likes to choose the optimal distribution among these cells, taking into consideration the shop floor's constraints. In order to analyze the performance of these optimal manufacturing systems and compare the effectiveness of cell formation, three well-known grouping efficiency measures have been used, namely the grouping index, the grouping efficacy, and the grouping capability. From table 1, we can notice that the two-cell solution with the same sum of voids and exceptions has the same efficacy, which is 0.445, regardless of decreasing the sparsity and number of operations inside the cells. In the two-cell formations, grouping index and grouping capability index are decreased as the number of voids decrease. The main principle of cell formation is to form cells with a minimum sum of voids or exceptions. Based on this principle, the designer will choose the system with the lowest E plus V, which is cell 4 or cell 5. But the main objective of grouping measures is to choose the cell with the highest quality, efficiency, and according to grouping measures, the designer will choose as follows. He will choose the 3 cell, but this 3 cell has higher value of E plus V than the 4 cell and the 5 cell. We can notice from this table that there is a contradiction between cells formed based on optimality and based on highest quality or highest efficiency. In the second table that summarizes the second case study of Nair and Narendran, it shows that the number of cells, sparsity, and the sum of voids and exceptions are constant for both cells. Based on these measures, the designer cannot choose the optimal or the best distribution between the two cells, V plus E 26, since the three grouping measures give different conflict evaluation. And here also, in order to choose one of the two systems, the designer may not depend on grouping efficiency since they may give conflict evaluation for both distributions. He may choose the distribution based on the shop floor's constraints. As a conclusion, we can say that in the first case, all distributions of the main system are optimal and the total of number of operation in the machine part matrix is constant. Grouping efficiency measures may not lead to choosing the optimal solution since the highest value of evaluation is different than the optimal distribution. The right decision will be based on optimality rather than efficiency. Also, the case where alternative optimal solution exists, grouping measures will make the designer more confused about the right decision. The decision will be taken based on minimum exceptions and voids. In the second case, the number of cells are constant for different distributions. Also, sparsity and sum of voids and exceptions are constant. The selection of one of the two systems may not depend on grouping efficiency measures, since they may give different conflict evaluations of the both distributions. The designer will choose the distribution based on the floor shop constraints. Here are some references that we were based on in our research. Thank you for your attending and bye bye.